students, I welcome you all to today's class. In today's class, we will be studying about vector product of two vectors. In the previous class, we studied about scalar product of two vectors, and in today's class, we will be studying about vector product of two vectors. In scalar product of two vectors, the resultant will be a scalar. And in vector product of two vectors, the resultant will be a vector. This is the difference. And the scalar product is called dot product. Vector product is called cross product. Vector product is called cross product. Okay. So what is vector product? So vector product or cross product of two vectors is another vector. Vector product or cross product of two vectors is another vector having magnitude equal to the product of two vectors and the sine of the angle between the two vectors. Magnitude equal to the product of two vectors and the sine of the angle between the two vectors. That is, if A vector and B vector are the two vectors and their cross product or vector product equal to C vector, which is equal to A vector, B vector, sine theta, sine of the angle between the two vectors. Okay. Now we can see the properties of vector product. In scalar products also we studied properties, is it not? The first property of scalar product is the product of two vectors will be a scalar, will always be a scalar. But here the first property is the product of two vectors in vector product will always be a vector. Okay. Vector, that is, the two vectors will be perpendicular to each other. Cross product into cross product, the two vectors will be perpendicular to each other. In scalar product, we studied that the scalar product is commutative. It obeys commutative law, but vector product is not commutative. That is, A vector cross B vector is not equal to B vector cross A vector. But in scalar product, A dot B vector equal to B dot A vector. Here, vector product A vector cross B vector is not equal to B vector cross A vector. Because their product will be equal, because A cross B and B cross A means A B sin theta. But the product, the value of the product will be equal, but the direction will be opposite. That is why this is not equal to this. Okay. Likewise, the vector product of two vectors is maximum when sin theta equal to 1. That is theta equal to 90 degree, and will be 0 when sin theta equal to 0 or theta equal to 0 degree. There we studied the self dot product equal to 1, but here the self cross product equal to 0. Okay, that is I vector or A vector cross A vector equal to 0, because A vector cross A vector means A vector sin theta. Here theta will be equal to 0 as the same product means theta will be equal to 0, and therefore sin 0 is 0 and the self cross product equal to 0. Therefore I vector cross I vector equal to J vector cross J vector equal to K vector cross K vector equal to 0. Okay, equal to 0. Then the next point is, in the case of these orthogonal vectors, if this is taken as I vector, this is J vector and this is K vector, I vector cross J vector will be equal to K vector. I vector cross J vector will be equal to K vector. J vector I vector and k vector plus I vector will be equal to j vector. It will be like this. I cross j equal to k, j cross k equal to I and k cross I equal to j. So what will be j cross I in the reverse order? I cross j is k, j cross I equal to minus k. Okay. Likewise, k cross j equal to minus I. Okay. In terms of components, the vector product of two vectors can be written in matrix form as A vector cross B vector equal to, these are the components Ax, Ay, Az, and is equal to, we know how to write this, I vector into Ax Bz minus Az By minus j vector into Ax Bz minus Az Bx plus k vector into Ax By minus Ay Bx. This is how to write the component of A vector cross B vector. This can also be written as I vector into Ax Bz minus Ay Bz, and here I have put a minus. If you take a minus from out, this will become plus Az Bx minus Ax Bz. That term will be coming in this place. Okay, we can also write it like that. Now, if two vectors A vector and B vector forms the adjacent sides of a parallelogram, then the cross product A vector cross B vector equal to AB sin theta will give you the area of the parallelogram. So, this will be a parallelogram. Since we can divide this parallelogram into two equal triangles, we can write the area of a triangle here as half into A cross B. Now we can see some examples of cross product of vectors. Top tau equal to R vector cross F vector. R is the displacement vector, F is the force vector, and tau, that is torque exerted on the object with this force, is R vector cross F vector equal to tau vector, that is it is a what? Vector product. So this has a vector at the back. Okay. Likewise, angular momentum L equal to R cross P. R vector cross P vector. P is the momentum, R is the displacement or distance between the 2 points. Then angular momentum L equal to R vector cross P vector. R is a vector, P is a vector, and angular momentum is also a vector.